Good morning to all. Today I am going to start the finite automata, how to construct the finite automata in the first unit. How to represent the finite automata. The representation of the finite automata. So in this, 5 tuples will be there. Okay, so in the finite automata is denoted with 5 tuples. Finite automata is denoted with 5 tuples. As I already told you, finite automata is nothing but finite number of states. Will be having the finite number of states. Okay, so 5 tuples will be there where M is the finite automata and the 5 tuples are Q, sigma, delta, Qs and F, where Q is the set of states. Okay, where Q is the set of states and sigma is the set of input symbols. What are the input symbols? What are the alphabets we are having? That is nothing but the sigma. And delta is the transition function. Qs is the starting state or the initial state. And F is the final states. F is the final states. Okay, so this final state can be any number of final state. It may be 0 final state or more number of final states can be there in the finite automata. So let me take one example how to represent these 5 tuples in a automata. Okay, so let us take this as automata. Okay, so these round circles are there, no? So that is nothing but states. Okay, what are number of states we are having here? Q is nothing but the set of states. So what are the number of states we are having here? Here is A, B, C, D, E. These are the states we are having here. So Q is nothing but A, B, C, D, E. And after that, sigma is equal to 0, 1. What are the alphabets we are having here is 0 and 1 in this example. And sigma, after sigma, delta is the transition function. So from where we are going? From one state with taking the input alphabet 0 or 1 going to another state. That is nothing but the delta here. So Q into delta tends to Q. So what you are taking here from A, suppose I am taking it as A and input alphabet as 0, I am going to another state. Okay, that is nothing but the delta here. Okay, and after that Qs is the starting state. Qs is the starting state. What Qs is the starting state here? What is the starting state in the above example I have taken here? A is the initial state. A starting state will be represented with this arrow mark and the final state will be represented with the double circle. Okay, so Qs is the starting state A and the final state is D because it is D is represented as a double circle here. So F is nothing but the final state. So set of all the final states are nothing but the accepting states. Okay, so in the finite automata, it can be represented in three ways, sorry. 3 ways we can represent the finite automata. What are those is transition diagram, transition table, and instantaneous description. Transition diagram, transition table. First, I am going to consider the transition table. So what is meant by transition table is where delta is the transition function here. From A, if you give the input, what is that you are going to get? See in this diagram. From A, if you give the input as 0, what is that you are going to get? B. Okay. So you are going to B state. So that's what we are going to represent it as a diagram here. A on 0 goes to B. A on 1 goes to E. B on 0 goes to E. B on 1 goes to C. So that means for which state you are going to give the input as sigma, then what is that you are going to have? Okay, C on input as 0, you are going to D state. And star, here star mark I am going to represent, no, this is arrow mark. Arrow mark is the initial state. Star mark is the final state. Okay, So here star mark I am going to represent here. That will be the final state. D on 0 is going to D. D on 1 is going to D. E on 0 is going to E. E on 1 is going to E here. Okay, that is the transition table. Coming three ways we can represent now: transition diagram, transition table, and instantaneous description. Transition diagram as already I have mentioned here. No, so this will be the transition diagram. Coming to the transition table, this is the transition table. Coming to the instantaneous description, this instantaneous description is nothing but the current state input symbol, current state comma input symbol is equal to the next state. Okay, so what is the current state? Initial state will be always the current state. So A on 0, we're going to which state? B. A on 1 is going to which state? E. B on 0 is going to state E. B on 1 is going to state C. C on 0 is going to state D. C on 1 is going to state E. C on 0 is going to state D. C on 1 is going to state D. E on 0 is going to state E. So that is the instantaneous description. So here every finite automata will generate a language. So the language generated by the finite automata is nothing but the set of strings accepted by the finite automata. What are the strings you are going to accept for that automata is nothing but the language generated by the automata. So coming to the Chomsky hierarchy here, Chomsky hierarchy. What is this Chomsky hierarchy is? See, regular languages, context-free languages, context-sensitive languages, and enumeration languages. Okay. So here, regular enumerated languages. So what are these regular languages? Are nothing but finite automata, finite state machine. And regular grammar will also be there. And PDA, CFL is nothing but context-free languages. So in this PDA will be there, context-free grammar will be there. And coming to the context-sensitive languages, this is context-sensitive languages. Here, linear bounded automata will be there and context-free grammar will be there. Coming to the regular enumerated language, that is nothing but the Turing machine. Here, unrestricted grammar will be there. So, we are going to discuss about mainly in the formal languages and automata theory, that is flat. We are going to discuss about the finite automata. Okay, push-down automata and the Turing machine. And sometimes we are going to discuss about the context-free grammars also. So mainly these grammars we are going to discuss in the compiler design. And these languages are finite automata, push-down automata, linear bounded automata, and the Turing machine we are going to discuss in the flat. Okay, so that is about the Chomsky hierarchy of the languages. Now, how to construct the automata? There will be a different steps of constructing the automata. So this is my own steps of constructing the automata. These particular steps is not at all available in any of the videos or any of the textbooks. So what I have knowledge in this automata, I have put in a steps format here. What is the step 1 is start constructing the automata. Okay. For the minimal valid input string. Start construct the automata for the minimum valid input string. Suppose language, whatever the language you are having here is 0, 1, 0, 1, 1, 0, 1, 1 like this. So what is the minimum? What W minimum will be? Minimum string should be accepted. Minimum string should be accepted here. Okay. So when 0, 1 are both are inputs, then what we can say, we can have both the inputs here, both the minimum strings here. And coming to the step 2, we have to specify the behavior of each and every state. What each and every state behavior you have to specify in terms of the read and expected values. What is the read value here? It is the minimum string required from the starting state to the current state. So what is the minimum string required to the current starting state to the current state is nothing but W read here. What is the minimum string required from the current state to the final state is nothing but the expected. Okay, read and expected values we have to calculate. Okay, So, and after that, step 3 is what are the missing input symbols? We have to check forward, backward, and also the self. And step 4 is if no state is satisfying the expected behavior, then we have to create a new state for the required behavior. So if what is that you are going to do, if you are not satisfying the condition, whatever you are having here, you have to create a new state. And if a particular input symbol is not satisfying the languages or the conditions, then what you have to do, you have to reject the input symbol. So if more than one state satisfying the expected behavior, then what we have to do, then construct the last read symbol to differentiate the appropriate state. Okay. These are the different steps I am going to follow for constructing the finite automata or the deterministic finite automata for constructing the DFA. Okay. So here, construct a finite automata for a formal languages over an alphabet. I am taking a simple example so that you can clearly understand the concept of the DFA or the construction of the DFA. Construct a finite automata is nothing but construction of DFA only. Okay. So over an alphabet sigma equal to 0, 1 in which every string contains a substring of 1, 0. So here what we have to do is first we have to know what is the length of the string. What is the length of the string is n. The number of states is n plus 1. If the length of the string is n, we can get the number of states as n plus 1 here. So what is the length of the string? What is in an example, what is the length of the string I have taken here? 1, 0. So that means length of the string is 2. The number of states will be 2 plus 1, that is 3. So I have taken in step 1 the number of states as 3 states. Okay, initial state is A and the final state is C. In between, I have taken the states as B. Okay, so what is the minimum string in the step 1? What I have taken, you have to construct the finite automata for the minimum string. So what is the minimum string? It should contain a substring of 1, 0 means 1, 0 must be there. Before that, any value can be there, and after that, any value can be there. So 1, 0 is the starting string, minimum string, and 1, 0 is substring here. We are having 1, 0 here. Before that, 0 is there. 1, 0. After that, 0 is there. 1, 0. After that, 1 is there. 1, 0. Before that, 1 is there. Okay, 1, 0 is there. Before that, any number of zeros can be there. 1, 0 is there. Before that, 0 is there. 1 is there. Like that, and so on. You can get any number of strings. All the strings must be accepted by this finite automata what we are going to construct. So first coming to A. Okay, initial state is A. So what we have to do in the step 2, we have to calculate the read and expected values. No. So what we have to do, what is the read value of A? What is the read value of A? You are not reading anything here. So that will be epsilon. If you are not reading anything, you should say it as epsilon. What is the expected value to reach to the final state? That is 1, 0. Okay. So coming to B, what is the read value of B? From A, you are going to B by reading 1. So what read value is 1. You have to reach to the final state. So final, if you want to reach to the final state, you want 0 again. And again, you have to calculate for C also. So what is that? What is the read value for C? It is 1, 0. What is the expected value for C? Nothing, because it is a final state. Nothing. So it is epsilon. Okay, it is a null string. So first we have to calculate A on 0 going to where? A on 1 is going to B, we know that. But A on 0 is going to where? We don't know. We have to calculate that. So what is the read value for A? Epsilon on 0 is going to where? We don't know. Epsilon 0 is there. But what we need to go to the final state? 1, 0 we need. 1, 0 we need here. So that is 1, 0. Where it is expected? 1, 0 is expected in A only. So we have to give the self loop for A, that is 0. And coming to B here, B on 0 is going to C. We know that. B on 1 is going to where? We don't know. So here, what is the read value for B? 1. On 1 is going to where? We don't know. 1, 1. And what is the expected value? 1, 1 is there. But what I need? I need 1, 0 as a substring. That means I have to get one more 0 here. So that is what I have given. What is the expected value? 0. Where is 0 here? There is 0 here in B. So give a self loop on B. And then C on 0 is going to where? We don't know. We have to calculate now. What is the read value for C? 1, 0. 1, 0 on 0 is going to where? We don't know. Okay. So already 1, 0 is there as a substring. So we have to give a nothing we need. Epsilon we need. Epsilon, where it is epsilon? In the expected C. So we have to give the self loop in C. And then C on 1 is going to where? We don't know. We have to check. 1, 0 on 1 is going to where? We don't know. 1, 0, 1 is there. That means 1, 0 substring is there here. That means you need epsilon. So epsilon, where it is there? In the expected in C. So give a self loop on C. So that is 0 and 1. Okay. So that's what you are going to construct DFA for with a substring of 1, 0. So the next topics I will continue in the next session.